Hi, everyone. My name is Ben Henning. I'm from Google.org, and I have had the opportunity to work on and with the Core Blockly team to try and figure out this how to bring screen reader into Core Blockly problem. And I'm hoping to talk a little bit more in depth on that, and maybe share some things that you haven't heard yet today. Largely, this isn't going to be a talk that goes into like the really nitty gritty of the implementation work. But I'm hoping to sort of talk a little bit more about the methodology and sort of the steps that we took in case anyone else finds that sort of interesting when you're trying to like face this intractable problem. To start with background though, we have to think about where we started last year. A lot of talks today about how V12 was largely based around keyboard navigation. And that was kind of like the key thing for V12. Trying to establish this fundamental navigation pattern that wasn't tab-based, that is kind of what you normally see on other websites, laid the groundwork, as well as this pattern of like really ensuring that user testing is the key fixation on, is it correct, is it the right way of doing things? Like both of these are transferable when it comes to the screen reader work. But another really key part of V12 is this concept of focus. DOM focus was the central tenet of how we implemented keyboard navigation. And this was actually really crucial. And I gave a talk about this in last year's summit. And I ended that talk saying, you can turn on keyboard navigation support today and it sort of works. Sort of being very heavy lifting. Because of the earlier talks that you saw, there were a lot of like graphic symbol, group. It wasn't very understandable. But it did lay the groundwork for the bridge of how to do the broader work. And so the main gap now was, how do you actually read out something that's useful and correct? But to start with that, we have to start somewhere. And so the idea is, let's build some fundamental basic proof of concepts that at least does something in the realm of correct. But we need to start with, what are the core things that need to be supported? And sort of that's just fundamentally blocks, of course, workspace and toolbox alike. Flyouts and toolboxes themselves, fields and connections, but kind of just more broadly, if you have a basic bare bones playground, can a beginner navigate to something? Are they likely to navigate to something? If they are, that's probably something that should have some initial support. The way to get something communicated is through ARIA. ARIA is a standards-based way of specifying readout contexts for DOM elements. And it uses a bunch of different properties in order to establish what is read out. There's the ARIA role, the label if you want to specify the element type, information about an override of role description, parent information, screen reader mode, combinations, and a lot of other stuff. Not really worth going into detail on all of these things. It's actually quite complicated when you're starting to unpack all the layers, but we're trying to do a proof of concepts. So let's just keep things really simple. We really just focused on, let's start with some roles and labels for those core components. And the idea is, let's just build something basic that works at least on one screen reader. I was the one that spearheaded the initial prototype. I have a Chromebook, so I was using Chromebox. And in order to pick an initial reasonable set of roles and labels, we actually started with trees. You can kind of conceptualize the Blockly workspace as an abstract syntax tree. Though it was mentioned earlier in Mike and Robert's presentation that that ended up being too much information, and so we pivoted from that. And beyond that, we also like tweaked the role descriptions. Role descriptions in ARIA are essentially a way of overriding the default readouts. So rather than saying tree item when a block is highlighted, it would read out block instead, which is also something we deviated away from later on from user feedback. But there's this sort of like fundamental approach, which is, let's get something to be read out, even if the word is literally just placeholder, so that users can at least get some sort of feedback. And if they're like, oh wait, this doesn't make any sense, we would iterate on it. And then beyond that, we built this in a way where we staged it on an experimental branch, and then we could easily deploy it so that we could share changes and iterations with partners. And that actually made it a lot easier to collaborate. And this kind of unblocked all of the later on work to start getting feedback from panelists and from user studies. I want to talk a little bit about some of the more nitty-gritty implementations, but I'm still going to keep this pretty high level, mostly because it's sort of interesting to see how you go from conceptual work into something that needs to be built for the long term, like Blockly V13. And a lot of technical design sort of hinges on the concept of principles. And so we grounded a lot of this work in these core fundamental principles. The first being, let's not break APIs, or not to introduce API breakages. We know a lot of applications depend on Blockly. We don't want new changes to fundamentally disrupt those integrations. And so this was a key thing. But at the same time, there were new APIs that were needed, and there was some level of enforcement that was important to ensure that there was some level of consistency, which kind of goes into my second one. This was touched on briefly in the keynote, but it's very important that users can switch between different Blockly applications without it wildly changing. And this actually comes across in the technical design a little bit with what sorts of things are customizable. Another key thing is largely trying to enforce and imply the real ARIA patterns for things that seem like they would fit. If something looks like a combo box, maybe it should be a combo box, though that ends up not being true. And separately from that, for the most part, we tried to ensure that there was consistency between both types of keyboard navigation users, those that used a screen reader and those that did not, though it's already been talked about a bunch today that there were exceptions to that, which kind of leads to my last point. Even though these are principles and they did foundationally affect a lot of what we did, there were exceptions, of course, and we had a decent amount of flexibility. Now, one sort of deeper element of the implementation is the block label composition, and what this really means is how do you assemble a description for a block. I'm not going to go into a lot of detail on what that looks like because it's actually very, very complicated, but instead I want to talk a little bit about like the overall goal, which is to create something that is roughly human readable, but otherwise prioritizes the navigation order of the blocks themselves. So you can see maybe in the images that the actual order in which the labels are composed into the final block readout, which is at the top, sort of follow the order that you would then navigate. Like the 10 in the repeat loop comes after repeats, but before the other labels. So that readout, when the block is focused, would then follow, pressing the right key would go to the 10 input and so on. And there's also commas here. That's intentional. Commas, and the idea of punctuation introduced this concept of prosody, which is to sort of slow down the screen reader or to provide users the ability to hear commas, because some readers support actually reading out certain types of punctuation. This is a suggestive thing. It doesn't necessarily guarantee anything, but it was part of figuring out how do we create the labels in a way that isn't so overwhelming, because they can be quite long sometimes. Now, while most of the work that we did was around ARIA labels, when it came to actually building the core functionality, there was also some stuff that was outside of ARIA. For example, there were cases when we needed to provide additional feedback dynamically, one of which is auditory feedback. This came up in a couple of previous presentations, but we introduced new sounds, we introduced tones when you're switching different levels when you're navigating. This is not something that just comes for free, and it's not something that Blockly had right away. And also, there are some cases where changing the state of something doesn't actually provide output. Move mode by default does not work in V12 with the screen reader. We have to do additional work around announcing the position that's contextualized and how it's changing. Beyond that, I mentioned earlier that simply turning on screen reader with keyboard nav is not sufficient because there's additional keyboard navigation changes that are needed. One of which is that looping mode, and what wasn't talked about was line wrapping. If you go all the way to the right, automatically continuing onward is a very useful feature for fully visual users, but for screen reader, it's also confusing, just like looping back around. Both of these had to be configurable, as well as having shortcuts to help the user figure out where they are. And these are substantial deviations over like the baseline V12 behavior. Obviously, all of this worked without any problems, right? Though, no. When it comes to using ARIA, there's a lot of gotchas. But before I talk about ARIA specifically, I'll talk about testing. So automated testing is important. I don't need to stand here and talk about that, but it's actually kind of more important when it comes to screen reader support. It's pretty likely that developers are not going to be checking every single screen reader that needs to be supported for every single change that's being built. And so how do you reconcile that? How do you maintain API stability? Aaron on the core Blockly team found this library called GuidePup, which as far as I can tell is maybe the only API right now, or framework that supports end-to-end testing for screen readers. It's actually quite good. It actually does drive the real screen reader. It does assert on the output, but it has some limitations. It only supports NVDA and VoiceOver, and it doesn't support test sharing because the idea is that the two frameworks could deviate substantially. And it's not the complete package. You can't, you don't want to necessarily test every single label and role change completely with GuidePup. When it comes to thinking about this from a standards perspective, there were, I would say, some pretty noticeable gaps with WCAG that maybe caused a little bit of complication. Largely, this sort of comes down to the fact that this is a standard seemingly designed for, basically 90s-based document websites. A lot of the troubles that we ran into kind of stems from one core concept. Developers aren't really expected to set custom roles as part of building a web page. And I didn't really talk about this earlier. Why does Blockly do that? Well, Blockly's SVG based. Part of the earlier examples that you saw with graphic symbol, group, comes from the fact that SVG elements have existing behaviors built into how the screen reader, or other existing ARIA properties. And so we needed to basically reinvent that entire mechanism from scratch because we can't just rely on semantic HTML for this. And that's a lot of where the complexity comes from here. Beyond that, I mentioned a bit earlier the need for dynamic announcements. This is not something that's built into screen reader support by default. There's some other complexities around like ownership and trying to hide elements from the node tree. And also this lack of universal customizability. What I mean by this is, we talked about combo box earlier. It's come up a couple times today. What that really meant is that by default, if you have something with the combo box role, some screen readers like JAWS will just automatically read out, press down to open, but that doesn't work in Blockly, which is why we had to switch to a more generic role button to be more declarative on what the actual input action was. There were some issues that we ran into with various screen readers themselves. Largely, this comes from WCAG not having strong opinions on what a reader should output. And this is why it's very, very, very important to test on every single reader that you are expecting your users to encounter, because they can vary a lot. And they can even sometimes change the navigation order themselves. One example of that is Narrator on Windows at one point in our testing would basically allow you to navigate to elements that did not have a tab index defined, which kind of boggles my mind a little bit. And that resulted in some very confusing bug report, or at least one really confusing bug report. And there's some level of bugs here that just seem to exist indefinitely. On Chromevox, regions don't, sometimes they just inconsistently announce when you exit and enter them, and they're not even necessarily consistent on when you're doing that. And tree and tree item don't work on VoiceOver plus Safari correctly, with role description, if I recall. So how do we solve all this? Well, kind of. There really aren't any perfect solutions. And instead, where we could, we preferred maximizing compatibility. So we picked solutions that would work for as many screen readers as possible. And if we couldn't necessarily do that, we would prefer the most commonly used ones. And some issues are just simply unavoidable. But that being said, there's this notion of self-consistency. We made sure Blockly works quite well on all of the major screen readers outside of mobile right now. And even though that sometimes may come with quirks, VoiceOver does have various quirks, but they're kind of consistent across all web pages. And so as long as it consistently works with VoiceOver, that's a pretty good place to be. And that's really what we were focusing on. And when it came to deciding between standards-based approach and other solutions, we would always prioritize making sure that it works with users. That was the most important piece, rather than technically following the standard, because sometimes it just didn't make sense. So I hope that was interesting, and I'm actually going to hand it over to Mike so he can start going into more depth on how the implementation works with block labeling.